Alright, this video is about cis and trans and EZ. Okay, these are ways of keeping track of the directionality of various compounds. This is with respect to double bonds, primarily, but also with respect to rings, because molecules are three-dimensional and they can go in different ways and things like that. So, cis and trans is the older version. They used it all over the place. Nowadays, this is only used for rings and for a particular set of circumstances. E and Z is the preferred model. Okay? But we'll cover cis and trans for how it was used in chains as well as how it was used in rings, just because not everybody is up to date. So, when you have a double bond, well, let's so you have carbon bound to carbon. Each carbon has two other things bound to it. Okay, so you can have carbon, 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 and so on. That's one way the bond could go. It could also look like this: carbon and carbon. Okay, and remember, you cannot rotate this double bond. Okay, that rotation does not happen. So if you have one of these two forms, that's all it can do. It can either go across the double bond like that, or it can stay on the same side. And that's where we can get the difference that we need cis-trans or EZ to talk about. So cis and trans, the old method would be to follow the chain. So this only applies to chains, and it's the method that is no longer approved of for naming chains. Okay? But this here on the bottom would be cis, this here up top, would be trans. Okay? Trans means across, cis means same. Okay? So cis means on the same side, cis on the same side, okay? Because they're both on the same side of the double bond. They're both on this bottom side, okay? Whereas trans means across, they're on opposite sides of the double bond, okay? So Transylvania, old name for what is now part of Romania, means on the other side of the woods. Trans-Silva, other side of the woods. All right. So that is the old method. It is no longer the approved method, just because it is only limited to a case where you can follow the chain across the double bond. Okay. If you can do that, then fine, cis and trans works, but it doesn't work for other situations, which is why they've come up with EZ notation for naming molecules that have double bonds. So you have your double bond, and you have your four things. So 1, 2, 3, 4. And what you do is you compare 1 and 2, and you ask, ooh, that's awful, which is heavier, okay, in terms of molar mass. Okay? And then you compare 3 and 4, and you ask, which is heavier. So in both cases, you're comparing the things bound to the carbon on the double bond. Okay, the left side and the right side, the carbon on either end of that double bond. You look at the two things, find out which is heavier. And then, okay, If the two heavier things are both on the same side, then it is Z. If they are on different sides, then it is E. Okay. E and Z come from German words. I do not know what E stands for. Z is zusammen. It means together. They are together on the same side. So Z, same side. Okay. And that's all there is to it. Now, sometimes this is easy. For example, carbon bound to carbon, and you have, say, hydrogen, fluorine, bromine, iodine. Which is heavier, hydrogen or fluorine? Okay. Compare these two because they're bound to the same carbon. Fluorine is heavier than hydrogen. Compare these two, they're bound to the same carbon. Iodine is heavier than bromine. So this compound, okay, is going to be E because they're on opposite sides. Sometimes it's a little bit more complicated. Okay, carbon, so carbon. So carbon, CH2 bound to CH3, 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 CH2, CH2, CH3. With this CH2, CH3 stuff, I'm just trying to show the chain without having to draw the whole darn chain. So you look at these two and you see the carbon directly bound to the carbon. The atoms directly bound to that carbon. They're both the same. So they would have the same weight, the same mass. So what you do then is you have to look at the three things bound to that carbon, or to that next atom. So this one is C goes to H, H, H. And this carbon, it goes to C, H, H. The first time you find a difference, the heavier atom wins. Okay? So now we have hydrogen versus carbon. Carbon is heavier than hydrogen, so this carbon has the heavier side to it. This could get really, really, really complicated if you have this thing that, branches and branches and branches again. I won't throw anything like that at you, just saying it's technically a possibility. In this one, likewise, you have carbon versus carbon, so you're going to have to look at the things bound to those. And what that gives you is carbon has hydrogen, hydrogen, hydrogen. This carbon has carbon, hydrogen, hydrogen. So again, this is the heavier one. So the heavier things are on the same side, Z, same side. Okay. Now I want to stress that cis-trans does not always come out the same as EZ. Okay, for example, this one does not have cis or trans, okay, because the main chain doesn't continue through the double bond. Likewise, but on this case, the main chain does continue to the double bond, and it just so happens that it is both cis and Z. But that's not always the case. So, for example, you could have C, C, CH3, CH2, CH2, CH3, CH3, OH. Okay. Now, the main chain goes through the double bond there, and it would be cis. Okay. But you compare them, okay, this, propyl, sort of, is the heavier one on this side, but the OH is the heavier one on this side. So this molecule is E. So cis-trans, EZ don't always line up. You can't assume that. So if you're naming it EZ, you have to use the rules for EZ. If you're naming it cis-trans, you have to use the rules for cis-trans. Now, when it comes to chains, I won't be asking you to name them cis-trans. Again, I'm just pointing this out for if you have to work with an old fuddy-duddy who didn't get the 2013 update. Now, rings do use cis and trans, but not for double bonds. Okay. Rings use cis and trans for when you're talking about things that are bound to the ring. Because these carbons on the ring, they still have 4 things bound to them. Okay, so the chlorine, iodine, and then on the other side, you'd have a hydrogen, and then you'd also have an invisible hydrogen. Okay, and then the other 2 bonds on each one are, continue in the ring. So when you bind something to a ring, attach something to a ring, it can be coming out of the plane of the ring toward you, or it can be going back behind the plane of the ring away from you. Remember, that's what these bonds represent. So triangle, out or toward you, and these dash lines means in or away from you. Okay. So cis and trans tell you whether or not those substituents, the things that are attached to the ring, are on the same side of the ring, cis, same side, or trans, opposite sides of the ring. Stupid laptop making noise. All right, so this one here, the chlorine is coming out, the iodine is going back or away, so this is going to be a trans chloroiodocyclopentane. 1 chloro, 2 iodo. Okay. Whereas this here, both coming out, this would be a cis dimethyl cyclohexane. Okay. So that's telling you not about double bonds, but about the direction with respect to the ring. Okay, that's all I want you to know about for cis-trans and EZ. But let's go ahead and see if I can't give you a flowchart. What if you have something like this? Over here, fluorine is going to be heavier than carbon. That's not a problem. But here you have 2 things that are the same. 2 hydrogens. Neither one is going to be heavier. So neither is heavier, so it's not E and it's not Z. So you just wouldn't label that double bond at all. Okay. You still have to name it. It's still an ene. But in this case, it would be, in terms of naming the double bond, or naming the compound, this would be 2-fluoro. Ooh, awful. I lost control pin there. Prop 1-ene with nothing special to name it. Okay? We don't indicate the E or the Z either way. Now, when it comes to naming E or Z, you put that out front, okay, for molecules that do have EZ. So in this case, we have just a simple butene, 2-butene, or but-2-ene. And this one is going to be E. Why? Because remember, up here you have the invisible hydrogen. Likewise, down here you have your invisible hydrogen coming off that double bond. So the heavier one is the carbon, and they're on opposite sides of the double bond, so it's E. And you would name this 2-E but-2-ene. Okay, so you just name the molecule as normal, but-2-ene, and then you put the E and Z information, all of it, if it has multiple double bonds, all that information goes out front. Okay, in parentheses, just sort of special in its own little place. So that can be as complicated or as simple as you could possibly wish. Okay, and in this case, what we have, ooh, this is a big molecule. Okay, so we got our main chain, we have our ethyl, we have our methyl, and we have 3 double bonds. Ethyl's going to get priority for numbering, so 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So we're going to number it from this direction. Sorry, that's not very clear. That's a 9. Okay. So it is going to be that big one. I'm going to need lots of room. 4 ethyl, 5 methyl, nona, 2, 4, 6. 2, 4, 6 triene. And then we're going to put, the EZ information out front. Opposite sides. This is E. You're going to have to work that out on your own. This one, 5 is a little bit more complicated. Same side. So this is Z. And this one is also E. So that's going to be 2E, 4Z, 6E. Okay. So that's how you would name that one. Just all the double bonds go out front. Okay. If the double bond is on a side chain, let me show you that as something like that real quick. Okay, we can do this. And then something like this. Okay. So this would be an ethylidene. And this is an ethenil. Okay. So 1, 2, 3, 4, 5, 6, 7. So this is 1, 2, 3, 3. Z ethylidene heptane, and this here is 1, 2, 3, 4. 1, 2, 3, 4. Okay, so 4. Oh, that one doesn't have. Okay, so I'll just go ahead and boom. Okay, so that's no longer ethenol. That is a prop 1 enil. Okay, I had to change that because as it wasn't easy. Because the ethenol had 2 hydrogens over on this far end. Okay, and thus, if they're both the same, neither E nor Z. So the propenyl is now E or Z. So 4, these are on opposite sides, so E, 1E, prop 1 enil, heptane. Okay. So the easy stuff always goes in front. If it's part of the main chain, it goes in front of everything. If it's part of a side chain, then it only goes in front of that side chain. All right, and that will do it for cis-trans EZ in terms of naming and numbering. For those of you who are more visual, I can go ahead and give you a flowchart of sorts. So ring versus chain. So we can come up here for the ring, come down here for the chain. So double bond, yes, then that is going to be EZ. No on the chain, no double bond, nothing. Okay. For the ring, double bond, yes. It is possible for rings to have double bonds that can be either E or Z. They have to be larger rings. The smaller rings, the double bonds will always just follow the regular structure of the ring. But for larger ones, you can get weird zigzaggies in the ring because of double bonds. So double bonds can be either E or Z, or just nothing. If you have a substituent with some sort of directionality indicated, meaning, if you see triangles or hashes, then if you see direction, then that's going to be cis or trans. No direction, so yes, no direction means you don't do anything. All right, so double bonds get E or Z. If you have a ring where you see the triangle or the hash mark, then you're going to do cis and trans. Now, chains can likewise have directionality. We'll be covering that later, if at all. So it's not covered yet. I'm just putting it on here for completeness. That's when you indicate chirality with R or S, and if you don't see any sort of direction, then you don't have to worry about it. And we're not going to worry about that for a while yet. All right, so there's the flow chart. It doesn't look like it would be very, very helpful, but you never know. So you have two possibilities in either case. Okay, and that will do it for cis, trans, E, and Z. See you later.